Greetings and welcome to Lecture 5.4, the difference of two squares. You may recall that a couple of lectures ago we had some special products that we did. One was quantity a plus b squared would give us the result of a squared plus 2ab plus b squared. A minus b quantity squared would give us a squared minus 2ab plus b squared. Then we had a plus b times a minus b, which gives us the difference of two squares, a squared minus b squared. Now that was front way and we're multiplying. Let's consider factoring. So if we see something in the form of a squared plus 2ab plus b squared, we know that ultimately that's going to be in the factored form of a plus b quantity squared. A squared minus 2ab plus b squared is going to give us the form of a minus b quantity squared. And the difference of squares, a squared minus b squared, is going to be factored into a plus b times a minus b. Here's an example. Let's factor 16x squared minus 25. The first thing you need to ask yourself is, can I factor it directly, as in taking out a GCF? No, I don't have a common factor here, so I need to look in my bag of tricks and see what other ideas I can come up with to factor this expression. I do see that 16x squared is a perfect square, as well as 25 is a perfect square. So 16x squared, if I break it down into its square, would be 4x quantity squared. 25 is 5 squared, so that's 4x squared minus 5 squared, and this is in the form of the difference of two squares. So I know I can factor it as 4x plus 5 times 4x minus 5. Now, if you're not sure and you want to check your results, then what you're going to do is use your FOIL method to multiply 4x plus 5 times 4x minus 5. 4x times 4x will give you 16x squared. 4x times minus 5 will get you minus 20x. Plus 5 times 4x gives you positive 20x. And 5 times negative 5 gets you negative 25. But as you can see, the middle two terms are going to drop out and give you 0x. So ultimately, we get right back to where we started from, 16x squared minus 25. Let's try another example, 36a squared minus 1. Again, there's some steps that I want to take before I try to attempt to factor this. I have a lot of bag of tricks now. So 1, there is nothing that I can pull out for a GCF. So the second is, I'm going to look to see if it is the difference of perfect squares. Is the first term a perfect square? Is the last term a perfect square? Well, 36a squared, that would be 6a, quantity squared. And a 1 is a perfect square because it's 1 times 1. So given that power in my hands, I can rewrite it as 36a squared minus 1 would be quantity 6a squared minus 1 squared. But now I write it up into its factors, 6a plus 1 and 6a minus 1. Again, if we want to go back and check our results, all we need to do is FOIL. 6a times 6a is 36a squared. 6a times negative 1 is negative 6a. 1 times 6a is positive 6a. And positive 1 times negative 1 is negative 1. The 6a's drop out, leaving us with 36a squared minus 1. Let's take another example to factor x to the fourth minus y to the fourth. At first glance, maybe you don't see that it will factor into the difference of perfect squares. But ask yourself, is x to the fourth a perfect square? It is. X squared squared is x to the fourth. Likewise, y to the fourth is a perfect square, which is y squared squared. So if I have two perfect squares and I'm taking the difference of those perfect squares, I'm going to end up saying x squared minus y squared times the quantity x squared plus y squared. But I'm not done. Take a look at x squared minus y squared. That in itself is the difference of perfect squares. So I do need to continue to factor this. So now I'm going to break apart the x squared minus y squared into x minus y and x plus y, leaving me ultimately with x minus y times x plus y times x squared plus y squared. Now at this level of math, we don't factor x squared plus y squared. We'll leave that to a higher math level, but you will be able to do that in the next couple of classes. Let's work with the example 25x squared minus 60x plus 36. Now it's not a difference of squares, but I do notice that our first term, 25x squared, is a perfect square, and 36 is a perfect square. Therefore, if I have two squares, I'm going to test to see perhaps maybe this is in the form of a minus b quantity squared or a plus b quantity squared. So the first term and the last term are perfect squares, and it does look like it's in this form, a squared minus 2ab plus b squared. I just have to figure out exactly is that the case. So 25x squared is 5x quantity squared. That fits. 36 is either 6 squared or it's negative 6 squared. So keep that in mind. It's one of the two, because 6 times 6 is 36, and negative 6 times negative 6 is 36. So we have an option here. But the middle term is 2 times 5x times negative 6. That's the only way we're going to get the negative there, is to have the negative 6. Because of that, now we can break it down into 25x squared minus 60x plus 36 will break down into 5x minus 6 times 5x minus 6. Or you can write it all together as 5x minus 6 quantity squared. Now let's work through a problem from start to finish and see how we can pull from our bag of tricks how to factor an expression. So 5x squared plus 30x plus 45. Now I do see I have a GCF. My greatest common factor is a 5. I can pull a 5 out of every single term. So I have 5 times x squared plus 6x plus 9. Now I'm going to test, is my first term a perfect square? Yes. Is my second term a perfect square? Yes, it is. Is that middle term twice times the perfect squares? It is. So how I can write this is 5 times, that's x quantity squared, plus 2 times 3x plus 3 squared. Because I know it's a perfect square, it's addition of two quantities that are the same quantity. It's the addition one. So I have 5x plus 3 times x plus 3, but that really is 5 times x plus 3 quantity squared. Now you can check this, you can go back FOIL it, and you should end up getting right back to 5x squared plus 30x plus 45. Now let's work with one more example. Now you may not see it at first, but this is a difference of perfect squares. My first square is x minus 3. My second square is 5. So my first square is x minus 3. My second square is 25. So I'm going to write this as x minus 3 plus 5 and x minus 3 minus 5. Now I do have some like terms in there, so I don't want to just leave it as is. So in essence, I have x minus 3 plus 5. I'm just going to drop those internal parentheses. X minus 3 minus 5. X minus 3 plus 5 is x plus 2. And x minus 3 minus 5 is x minus 8. And that's it. We did reduce it down or to the factors involved with this problem. But the cool part about this was I didn't have to immediately FOIL that x minus 3 out. I saw that it was the difference of perfect squares, and using that knowledge, I made the problem a little simpler. Now I could have FOILed that out. If you don't see it immediately, you could use all the tools that you have at your disposal. So x minus 3 squared is going to be x squared minus 6x plus 9 plus 25. Pardon me, minus 25. I'm going to add like terms. So it's x squared minus 6x, 9 minus 25 is minus 16. So now I need two numbers to multiply to negative 16, but add to negative 6. So my real only choices are 8 and 2, and since the middle term is negative, my negative is on the larger number. So I know it's going to be x minus 8 and x plus 2. Those answers are exactly the same. So whether you see that it's a difference of squares first, and then use that knowledge to get down to your factors, or you go ahead and FOIL the square out, add like terms, and then find the factors, either way, you'll get the same answer. So until next time, be seeing you.